Welcome again to my channel Exam Warrior. In this video I am going to discuss about ambiguous grammar. So the computers are very logical systems. We cannot have two methods of doing one thing. Means that if the computer sees that there are two ways of doing a thing, then it poses some ambiguity to the computer. So in that way only we have the grammars stored in our computer, and if the grammar suggests that this can be done in two ways, then computer get confused. So we need to have a very determined and very deterministic grammar which is to be used by computer. And if the grammar poses a problem to the computer, that is ambiguity to decide which action to take, then that grammar is ambiguous. Suppose we are adding three numbers, 2 plus 3 plus 5. Now they can be added in two ways. Firstly, I can add these two numbers 5 and then this 5 plus 5, that is 10. Or there is another method. Firstly, I can add these two numbers and then answer 10. Now if the grammar suggests that this can be done in two ways, then the computer will get confused which way to choose. It does not have any decision power. So we need to have a grammar that is not ambiguous and helps the computer to decide in a very deterministic way. So in this video we are going to see some examples of how to prove the ambiguity of the grammar and how to detect it. So our first grammar is very simple, that is E produces E plus E or small a. There is no perfect algorithm of detecting whether a grammar is ambiguous or not. This is totally based on guessing. We need to guess a string, and if we are able to generate two parse tree for the same string, then the grammar is ambiguous. Generally the parse tree suggests how we are going to solve the string. So suppose I am guessing one of the string a plus a plus a. So let's generate the parse tree for that. E, using this production rule, E produces E plus E. I am going to produce E plus E. Again I am going to use the same production rule and producing E plus E. I am going to use the production rule E produces A. I am going to generate A. So I have generated A plus A plus A. So this string is generated. But is this the only method to generate the string? Can we find one other parse tree? If we are able to find that, then the grammar is obviously ambiguous. So let's see. E produces E plus E. This time I am going to expand this one. E plus E. Again using E produces A. Now it also produces A plus A plus A. So we are able to generate the two parse trees for the same string. That's why this grammar is ambiguous. Now let us see what has happened. That firstly in this grammar, firstly we are solving this tree, then we are adding the result of this tree to this tree. So firstly these two are solved and then added to this. In this one, firstly these two are solved and added to this one. Firstly these two are solved and added to this one. So this poses the ambiguity to the computer. Let us see some more grammars to have a concept on how to detect the ambiguity of the grammar. Let us take another grammar. S produces E plus E, E star E and A. I would suggest you to pause the video and try it yourself. So let us guess the string A plus A into A. Let us have this variable as E only. Now we are going to generate the parse tree for this. If we are able to generate two parse tree for this grammar, then this grammar is ambiguous. Suppose E produces E plus E and then this one produces E star E. Using the production rule, E produces E star E, and then using E produces A, we can do this. Now can we draw another parse tree? Let us see. Using the E produces E star E. Using the production rule, E plus E produces E plus E. Using this. So what we have generated, A plus A star A. A plus A star A plus A star A. So both the trees are giving us the same string generated. That's why this grammar is also ambiguous. So what we have to do to find the ambiguity grammar, just consider a string, just guess a string and just draw more than 2 parse tree for that. Let us see again one more grammar that is little bit complex. Suppose we have the grammar S produces SS and AB, A produces AA and A, B produces BB and small b. I would again request you to pause the video and try it yourself. So let us consider the string AB, AB and AB. Can we draw 2 parse tree for that? If the grammar is ambiguous, then we can do so. So suppose S produces S and S using this production rule, and then S produces A and B. Here also S produces, here we are going to say S produces S and S. Now here A produces A, we are going to use this production rule, and B produces B. We are going to use S produces capital A and capital B, this production rule, and here also S produces capital B. Using this we are able to generate the string. So now I am going to show you the one more parse tree for the generation of the same string. S produces S and S, this produces S and S produces A and B, this produces A and B, A and B, this A, this B, this A, this B. You can verify that I have used all these production rules, mainly this one, and I am able to generate the 2 parse tree for the same string. That's why this grammar is ambiguous. Thank you.